Let us share the screen. Wait. Okay, we will continue with the elliptic PDE. The example of elliptic PDE is Laplace and Poisson equations. So these two equations also we use by the different methods. Okay, so I explain to you. Okay, first and foremost, we go to the equation of Laplace and Poisson. Okay, the equation of Laplace and Poisson. Dah bangun semua? Okay. For the Laplace equation is like this. Laplace is a second partial derivative of u respect to x plus with second partial derivative of u respect to y. So equal to 0. So for this one, that means u, x, y. So now the independent variable is x and y. And for the Poissons, basically it's the same, only the right hand side is not equal to 0. It is some function there. With some function. Adalah function tu. Okay. So it can be like have x inside or maybe don't have x. It can be like x squared plus 2y plus 4 any function. Okay. So the left hand side is the same. So both x and y is independence variable. So here, what is the difference between this elliptic PDE? Okay, this is a elliptic PDE. So is this one. Before this, the heat and wave equations, I mean the parabolic PDE and also the hyperbolic PDE is the independence variable is x and t. Before this is like this, right? Okay, so that when we draw the grid, the x axis is x, the y axis is t. But now the y axis is y. Sekarang adalah y. Okay, so now we continue to from this one. Okay, I start with the Laplace equation because here is equal to 0. So now the step is the same. Okay, we still have to draw the grid, consider the boundary conditions. Okay, and then after that we have to write in the finite different form. So in this one, if let's say this one I write in the finite different form, so it will become like this. Kecil sikit. So this is will be, because this is respect to x. Okay, so because respect to x, the step size of x is h, and then when this is respect to x, so we are going to change the I. So here will become ui minus 1j minus 2uij plus with ui plus 1j divided by h square. So ini boleh Okay. And then continue plus with this one. This one, second partial of u respect to y. So y, kalau y, that means the step size of y we use k. And then what will change is j. Okay. So kat sini, Here will be uij minus 1 minus 2 uij plus with uij plus 1 divide by k square. Okay, yang ni yang berubah j minus 1, j plus 1. And then this is k. And this one is h step size. This is I minus 1, I plus 1. Okay, so now let's say we assume that let h is equal to k. Okay, if let's say h is equal to k, so now sama dengan, so both here, this one and this one is equal. If let's say this one and this one I bring to the right. Okay, I bring to the right and then multiply with 0, so become, here will become u I minus 1 j minus 2 u I j plus u I plus 1 j plus with u I j minus 1. Okay, here is another u I j. Ini kan macam ni lah. Sini ada negative 2, negative 2 uij, here is negative 2 uij, and here is plus, so become negative 4 uij. So here I will change to 4 uij, and then continue plus uij plus 1 equal to 0. So this is because the Laplace is equal to 0. Let's say this is Poisson. Okay, let's say this is Poisson. So this is some value. Let's say this is fx ke. Saya cuma, it can be like this lah. Let's say like this. Okay, katalah macam ni. So here when I bring to the right, so it become h square somewhere. Okay, it's time with x square plus 2y plus 4 lah. Macam ni. Okay, boleh. So because now it's 0, so I just put in 0. Boleh, Hafizuddin?
Boleh.
So sekarang let's say saya balik kepada, so I go back to the Laplace. Okay, so because of Laplace, because here is 0, so it's continue become 0. So sekarang saya just jadikan kosong lah. Okay, so I just put it as 0 for the Laplace. So if now, if look at here, we will have, now we have I minus 1j. Saya akan lukis. This is ui minus 1j. Okay, and then we have, inilah ui minus 1j, and then we have uij, ini uij, kan, and then here is, wait 1, this one is negative 4, and then this is ui plus 1j, this is ui plus 1j, here ui plus 1j, so this is 1, kan, tambah lagi plus with this is uij minus 1. This one, uij minus 1 is this one. So this is 1. And then another one, the last one is this one, uij plus 1. So uij plus 1 sebelah atas here. This is uij plus 1. Okay. So here this is 1 as well. So, and then equal to 0. Boleh. So this is the molecule graph. Okay, so the molecule graph is look same with the wave equation, right? But the difference is now the target cell, that means the one that we want to find is actually at here. The target cell is at uij. Sebelum ni target cell kita normally we use this one, right? UI J plus 1 kan. Tapi sekarang ni adalah our target cell here. Kat tengah-tengah. Okay. So this is the target cell that we want to find. So means that, okay, when we draw the grid for the Laplace and Poisson's, let's say this is Y, this is X, right? And normally we have a grid like this. Kan? We have a grid like this. Okay. So basically the initial condition will get the value here, right? And then we get the boundary condition, boundary. Okay, this one you learned in the heat equation and wave equation before. And for this elliptic PDE, okay, dia akan diberi boundary. That means keempat-empatnya, including here on the top. So that means we only have to find at the middle here. These four only. Okay, so if look at here, I want to put this molecule graph is become like this. Ni lah. So boleh. So sekarang dia bukan kat bawah ni dah. Yang J minus 1. Tak macam, it's not like the wave equation. The wave equation that we have to eliminate. The J minus 1 for the level 1. You remember? Okay. But this one you don't need. Because, okay, the target cell is this one. This is the target cell. Okay. And then, so here, and then we move this one to the right like this, and the next one is this is the that target cell is on the center here. And then move again to up, go up, and this is target cell. Sorry. This is target cell, another target cell, and then move to the right, and then we will find this one. So basically, for the Laplace or Poisson's, when you have here, you look at this one, this one, look at here, we have 4 unknown here. But so when we have 4 unknown, basically we have to have 4 equations to solve this one. Okay, so that's why it's really important for you to write all the name of this grid from 0, 0, use any 1, 0, and so on. Any, because you want to know what is this one, what is this one, what is this one, what is it. Okay, so boleh. So now we go to the example. Okay or not? So far, okay or not? Class, if you're okay, then you type okay. If not okay, then you type X. So how about the others? Setiap kali ni je. Daniel Izzuan. Okay tak awak? Muhammad Daniel Izzuan. You okay tak? Okay. Thank you for your response. Okay, now we go to the okay. So just now, ingat so this is a Laplace. The right side is 0, and if let's say this is a Poisson, that will have some value here. So when some value here, remember this one we have to bring to the right. Okay, so I think that only. So now we go to the example. This one. Ini boleh saya gerak ke sana. The whole thing. Okay, we go to the example 9.8. Example 9.8 is on page 237. Okay, so here it said that the Laplace equation, okay, second partial derivative of u respect to x plus with second partial derivative of u respect to y equal to 0. For x larger or equal to 0 and smaller or equal to 1, and y is the same. Okay, and with the boundary conditions, okay, is now for the Laplace and Poisson is give you the boundary conditions, okay? Because left, right, bottom, top, all the value we have to fill in. And then solve the Laplace you by using the finite difference method with, saya tersilap with, sekejap I write the question but with h equal to step sign of x and then k equal to step size of y equal to 1 over 3. So k and h are equal, okay? So we start with draw the grid. Step, besarnya. Wait Step 1. Draw the grid. Okay. So now, sekejap So remember 0 until 1 with the step size is 1 over 3. Okay. 1/3. So I will draw this one. This is y. This is x. So let's say this one is 0. This one 1 over 3. 2 over 3. 3 over 3. So yang ni pun sama. 1 over 3. 2 over 3. 3 over 3. Ataupun 1 lah. I write 1 lah. Senang. This one is 1. This one is 1. Okay. Okay. Now we have to write the name of each point grid. So at this point, this is U0, 0. And at this point, this is U10, U20, U30. And here, this is U01, U11, U21, U31. This is U02, U12, U22, U32, U03, U13, U23, and then U33. Okay. Jadi ulang balik, just repeat what you learned previously. Okay. Ahmed tak ada. Ahmed memang tak keluar. Ahmed, you just join the class? When you join the class? Ahmed Mohammed, when you join the class? Ahmed,
Yes, doctor?
when you join the class?
Yes, I joined about 10 minutes ago.
Oh, okay. What time is your hometown now? You're at your hometown, right?
It's 2 a.m.
It's 2 a.m. So how about the
Yes.
test later on in the final? So you have to be awake.
Yeah, of course, sure.
Okay. Take care. Shafiq here, Shafiq, Muhammad Shafiq. Ada kat sini? Muhammad Shafiq.
Yes.
Shafiq, bila awak masuk? Awak baru masuk
Yes, doctor. Sorry, doctor.
So awak masuk tu kat mana? Sempat. Heat equation, wave equation, okay So ini yang Laplace
Okay.
Shafika, are you here, Shafika? No, Shafika? No, Shafika? Tak ada. Tak ada. Okay, never mind. Okay, now the second step, similar to the previous one, we have to consider the boundary condition. Cuma sebelum ni we have kita initial and boundary, but this one because all are consider a boundary lah sebab semua boundary conditions. Okay, so given here, you look at here, we start with this one. This one, okay, you remember when I write this one, u, x, y. So kalau sini, that's mean, if let's say here is right, u 0, y equal to 0, that's mean when the x is 0. Here, this one x is 0. When x is 0, the value of u is 0. When x is 0, that means x is here, right? X is 0, that means this point, this point, this point, this point. So including there. So when x is 0, this means this one. Yeah. So this one will be all 0. You see? So this is the first boundary condition. So here the value is 0, 0, 0, 0. Okay? And then the second conditions. Okay, this one is just now this one. So the second condition is when x is 1, okay, u is equal to sine 2 pi y. This one. U 1 y equal to sine 2 pi y. Okay, so that means when x is 1. And then for any other value of y. So here, that means here, x equal to 1. Ni x equal to 1 here. So that means this point, this point, this point, this point. So many, meaning that is including U30, U31, U32, and U33. So let's say this one. So I color in here. So either you want to calculate one by one. Contoh macam ni. So start from U30, okay? So U30 equal to sine 2 pi. At U30, y is what? Y is Nurul Fatimah. Y is when here U30. Y is the value of y is apa? Fatimah, are you here?
Yes.
Nilai y apa? The value of y?
1/3.
30 kat sini sebenarnya 30. Nampak?
0, 0, 0.
This is here 0. Kan 0 sini. So this is 0. Okay. So when U31 sine 2 pi Faisal Izani, U31, the value of y is Faisal Izani. Faizul Izani. Here? Kemana? So that means class. This value is
1/3.
1/3. Syafiq 1/3. Kat sini. Kat sini. Awak tengok ni. Ni. 1/3. Boleh? Okay. So you can write like here, like this. So awak carilah. Okay, using calculator. Sekejap guna calculator. Where is the calculator? using the calculator. So you can just press, okay, sine 2 pi y and sine, okay, remember, because this is sine, you have to make sure your calculator in the radian mode, okay, in the radian mode. So 2, sorry, 2 plus sine 2 shift pi alpha y, tutup kurungan, and calculate the value of y. Start with dengan sini, the value of y is sini 0 kan, 0, so you get 0 here, and then the value of y is 1 over 3. So calculate again, the value of y is 1 over 3, so you get 0 0.866, 0 0.866. Wait, so here sine 2 pi 2 over 3. Alamak. You get, okay, get berapa? Calculate 2 over 3. So you get negative 0.866. Yang ni, maksudnya sini kosong, here is 0, here is 0.866, here is negative 0.866. Okay, if you don't want to do one by one like this, you can use table. Okay, use table. So let's go to mode and then find table number 7. Okay, and then fx. So fx here, you have to key in this equation. But because in the calculator they use fx, it's fx, bukan fy. So here you have to change to sine 2 pi x. Boleh? Sini kan, dalam ni this is y. Tapi now you change to x. Yang unknown ni. So if you ask what is fx, so you just key in this one. Sine 2 shift pi. Y kan sepatut. But now because this is fx, so you put x, alpha x. And then if we ask you, how about gx? We don't have gx. We only have one equation. So this becomes 0. Okay, so start with, look at this y. Y yang kita nak ambil daripada start from 0 until 1. 0 and then n is 1. With the step size 1 over 3. 1 over 3. Okay, so you get the answer. When y is 0, u also 0. When y is here, y is 1 over 3, the value of u is 0.866 here. When y is 2 over 3, that means 0.6667, then the value of u here is negative 0.866. And when the value of y here is 1, the value of u here is 0. So this is 0. Boleh tak? Okay or not? Ada yang tak
Okay.
faham? So if you okay, then you press 5. You type 5. Not okay, then type 6. Half, then 7. Okay. Okay, now okay. So if let's say, so ini, okay, dah settle left and right. The boundary when x is 0 and the boundary when x is equal to 1. So, and then we go to the next one, the third one. The third one is this one. It says u x0 is equal to u x1 equal to x1 minus x. Okay, for x from 0 until 1. So kalau maksudnya here, that mean u x0, kalau this one, this mean, this actually means that when y is 0, kan? When y is 0, Kalau when y is 0, that means this one, kan? This here, this boundary. Mungkin sini saya pecahkan. Okay. So, dia sama dengan is equal to ux1. ux1 is that mean y is equal to 1. Okay. So, y is equal to 1 is here. 1. Sini. Means that this value, this value, this value, this value. Okay. So, ini adalah here. This one. Okay. So, equal to x1 minus x. So, okay, either you want to calculate one by one like this one, that means start, okay, so because u00, we already calculate just now, right? So, okay, it doesn't matter. You can try to calculate again and check whether it can get 0 or not. Let's say this one, when u00 here, this one, kan, the value of x is 0, 1 minus 0, okay, that's equal to 0. Sama lah. Let's say in case, let's say when you use another boundary condition, you cannot get this 0. Let's say you get 5, katalah. Okay, I just assume. Let's say you get 5. So which one you want to take? You want to take 0 from the previous, let's say I put 5, right? You want to take 0, kejap, or from this one, 5. Which one you want to take? Okay, if let's say it's happened that there are two different value, but the boundary condition cover for both, so you take the average value. Okay, that means 0 plus 5 divided by 2, so that means 2.5. Okay, or not? If, tapi biasanya it should be can get the same answer. Tapi ada juga kemungkinan dia punya boundary condition, because why it become like this, because now we are doing approximation, okay, not the exact value, approximations. So here this is 0. Sorry, 0. And when you 1 0 here, that means the x value is 1 over 3, 1 minus 1 over 3, macam tu. So equal to berapa? So if let's say I want to use table, so you just use table. So let's say I use table 7. Okay, fx, I will use this formula, x in the bracket alpha x in the bracket 1 minus alpha x. Okay, close the bracket, and then I press calculate. Okay, sorry, bukan calculate, equal to, and then gx is 0 because we only have one equation. Okay, start with, so the x is start from 0, and with 1, with the step size is 1 over 3. 1 over 3. So equal to, okay, now you get the value when x is 0, the value of u also 0. So here 0, here also 0. Bawah ni, sini 0, here atas pun 0. Because they are same. Now, when x is 1 over 3, the value of u is 0.2222. So here this is 0.2222. Maksudnya ni 0. And on the top here, u13 pun sama. 0.2222. And then here, when x is 0. When x is 2 over 3, okay, the value of u is 0.2222 as well, 0.2222. 2 as well. Sebab yang ni U20 is equal to U23. This one. So equal to 0.2222. And then last one, let's check whether we can get 0 or not. So when x is 1, so the value of u is 0. So here 0, here 0. Okay, so far okay, class. If you're okay, then you type okay. So far okay? All okay? Boleh? Okay. 3 je. Okay. Now we want to find this one. Yang kita nak cari adalah U12, U11, U22 and U21. This is 4 value that we want to find. Okay, so after we consider all the boundary, so next we have to write this formula in the final different form. So step seterusnya, step 3, write in final different form. Nah, dia baru keluar. Write, sekejap. Write in finite different form. So finite different form, second partial derivative of u respect to x plus with second partial derivative of u respect to y equal to 0. So change to find a different form. Ui minus 1j. Saya turun sekejap I bring to the turun sikit. Tak dapat. It's hang now. Wait ah. Wait ah. Tak boleh gerak. Biarlah. Okay, now this one 2uij kita keluar. Plus ui plus 1j divided by h square plus with uij minus 1 minus 2 uij plus with uij plus 1 k square equal to 0. So the value of this one is ni kan 1/3 kan. So here I change double change pun tak apa. Saya tu jawab 1/3 square. And k is same 1/3 square. But later on these two we bring to the right. So now tinggalnya ui minus 1j minus 4 uij plus with ui plus 1j plus uij minus 1 uij plus 1 equal to 0. Okay. So ini, so you will get the step 4, draw the molecule graph. So this is uij plus 1, uij, uij minus 1, ui plus 1j, ui minus 1j. So this is 1 1, negative 4, 1, 1 equal to 0. So yang ni yang kita, we will bring to the yang tekuk kat grid tu. So this one, so this one we want to put here. So saya keluarkan this one. Boleh sebelah kiri pula. To the left. Okay, now let's say this one in. This 4. So this one I will put it here. This is Uij. This is one what I want to find. And then delete this one first. Wait. And here is Uij plus 1. Yang bawah, the left, here, then the right here. Boleh. Okay. Now, refer to this one. So the first one, you will get like this. Okay, this one is our first equation that we were going to find. Okay, so here, you look at here, here is 1, right? 1, U, 1, 2. So U, 1, 2 plus with, sebelah sini pula. 1 time with this one, with U, 0, 1. Di mana, where the U, 0, 1 is the value is 0. Okay. And then plus with, no, bukan plus. Here, this is negative 4. Nampak? So 4 times with this one. This one is U11. Plus with here. 1 times with here. U21. And then plus with U10 equal to 0. And where the value of this one is 0.2222. Okay. So now I simplify it. So it become negative 4U11 negative 4U11 plus U21 plus U12 equal to negative 0.2222. Okay. So far okay? Boleh? Class. So this is the first equation. So we get the first equation here. So this is the first equation. Okay or not? Class. Boleh? If you okay, then you type 1. Tak okay, then you
One.
type 2. Ulang. Syafiq seorang. Yang lain? How about others? Okay or not? Boleh?
Boleh, Doktor.
Okay. Okay. Now, we continue. Bring. Dia tak boleh satu semua. Alamak. So, this one bring to the right. This one. Delete. This one bring to the right. Lah. Okay. So, the second one is become U22 plus with U11 minus 4U21 plus with 0.866 plus with 0.2222 equal to 0. Ini ada satu lagi 2. So now the second equation will become u11 minus 4u21 plus with u22 equal to, so here negative 0.866 minus 0.2222. So we get negative 1.0882. Negative 1.0882. So this is the second equation. And then we move up. This one. Now, this one become, the third one, 0.2222 plus with 0 minus 4u12 plus with u22 plus with u11 equal to 0. So here become u11 minus 4u12 plus with u22 equal to negative 0.222. And this is the third equation. Okay, boleh. Semua dah tidur ke? Masih ada ke sini? Still here? Are you still here with me?
Yes.
And then
Yes.
now here, this one move to the right, this one move to the right, this one move to the right. Tak bergerak pula. Sudah hang. Sekejap. Okay. Now, kita kecilkan sikit. The fourth is u 0.2222 plus with u12 minus 4u22 plus with, this one is the value is should be negative 0.866. Negative 0.866 plus with u21 equal to 0. So now it's become u21 plus with u12 minus 4u22 equal to, so here 0.8666 plus with 0.2222. Sorry, it's minus. So get 0, silap, 6438. 0.6438. So this is the fourth equation that we get. So now we have to solve this using system of linear equation that you learned before. So let's say rewrite in a metric form these four equations, empat ni. Let's say I write in metric form. So this one not necessary, this step. So because this one is more easier when I want to draw in a metric, change it into metric form. So here we have negative 4, 1, 1, and we have another one is 0. So this one is u11, u21 U12 and U22 equal to, this is negative 0.2222. Then the second one, U11 is 1, U21 is negative 4, U12 we don't have, we have U22 is 1. So this one is negative 1.0882. And then the third one, U11 is 1, U21 don't have, U12 negative 4, U22 is 1. So this is negative 0.222. And then the last one here, U21, okay, that means U11 don't have, U21 is 1, U12 is 1, U22 is negative 4. So this is 0.6438. So what method we want to use if you have this matrix? So if you say that Gauss eliminations, then I will not suggest, because if Gauss elimination, you have to eliminate here, eliminate here, eliminate here, eliminate here a lot. So you have to do the eliminations quite a lot. So this one seems to be like, this one even you can use for Kolesky method, okay, Kolesky method, because this is positive symmetric positive definite, can. And also this one is the diagonally dominance, so we can use Gauss Seidel iteration, okay, so you can use Gauss Seidel iterations method. Okay, masih ingat tak? You still remember Gauss Seidel iteration? Masih ingat tak? Syukri, Muhammad Syukri, masih ingat tak? Syukri Jalal. Macam mana dah Gauss Seidel iteration? Syukri, are you here, Syukri? Dah tidur?
Ya doktor, ada.
Gauss Seidel iteration, ingat lagi macam mana tak?
Tak ingat lah doktor.
Okay, so Gauss Seidel iterations macam ni, kita dapatkan, we get the formula for each of this value. Yang ni setiap ni kita dapatkan. Okay, so based on this one just now and this equation, you remember the first equation, this one, this first equation, right? First equations, from first equation you dapatkan this one, U11 equal to, so all bring to the right, so negative 0.22222, okay, minus U21 minus U12 divide by negative 4. Boleh? So dapatkan ini. So the rest bring to the right. Boleh? So same here. So okay. So I write here. Start with the first one. So I will using Gauss Seidel iteration method. So U11, saya besarkan sikit, is equal to negative 0.2222 minus U21 minus U12 divided by negative 4. So U21 is equal to negative 1.0882 minus U11. Okay, don't have this U12 don't have, so directly minus U22 divide by negative 4. Boleh? Okay or not, class? Okay, then you type okay. Okay. Okay or not? If okay, then you type okay. Then Seorang je. Syafiq seorang je. What are the others? Others okay or not? Yang lain, how about the others? Negative 0.2222 minus. So here we have U11 and U21 we don't have. And then the next one is minus U22. So here is negative 4. So continue with the last one is U22 is equal to 0.6438 minus U11 tak ada. We have U21 minus U12 divide by negative 4. So boleh. So we will easily, if let's say I can put in the symbol that we will easily key in the formula. So let's say this one, we assume this one is as A, this is a B, this is C, this is D. So here is A equal to negative 0.222 minus U2A is B, minus B minus C divided by negative 4. So this one is B equal to negative 1.0882 minus A minus D divided by negative 4. So this is C equal to negative 0.2222 minus A minus D sama negative 4. And then D is 0.6438 minus A21 is B minus A12 is C divided by negative 4. So yang ni masuk dalam calculator. And later on we solve by using Gauss-Seidel iteration. Kalau Gauss-Seidel iteration, you remember that we have to draw the table like this. So start from K. So this is U11, U21, U12, U22. So this is A, B, C, D. So we have to do the iteration. We do the iteration, iterate until a maximum untuk for the x k plus 1 minus x k is less than epsilon. So kita check yang bawah tu minus yang atas tu berapa. So bawah minus atas if less than 0.0005, then we can stop. So okay, saya ulang balik. Kiranya that's mean kiranya buat ulang kaji. Okay, now start from 0. So from 0 we will put all the value here A, B, C, D. Okay, is 0. So we key in the calculator. Remember, key in the calculator. We key in all the equation together. Okay, start with the first equation. This one. Start with this one. Okay, put alpha A, alpha equal. Okay, alpha A, alpha equal. And pecahan macam ni. Okay, negative 0.2222. Okay, minus alpha B and minus alpha C. Here, go down negative 4. Okay, so bring to the right, we put this symbol. Remember this one, double dot? We put this double dot, so you can find this double dot at here to press alpha and this integrate. Okay, it's come out double dot and continue with the equation B here. So alpha B, alpha equal pecahan negative 1.0882 minus alpha A minus alpha D divide by negative 4. Okay, bring to the right, key in this symbol, double dot. So here alpha integrate. Okay, so continue with C. So alpha C, alpha equals, okay, negative 0.2222 minus alpha A minus alpha D divide by negative 4. Okay, and then bring to the right, double dot again, put double dot again, and then we continue with D, the equation D. Okay, double dot, and then equations alpha D, alpha equal, pecahan sini 0.6438 minus alpha B minus alpha C divide by negative 4. Okay, so done all. So you press calculate. Calculate here. Press calculate. So we start with the B. B, this is B. B is 0. C also 0. Equal to D also 0. So this is the value of A. So continue this one. This is D. This is A. Yeah. Okay, so A is 0. Sorry, 0.0556. Okay, and then press equal to, so this is B. B is 0.2860. 59, sorry, 59, 59, and then press equal to, so this is 0.0694, and then equal to negative 0.0721. So, and then press equal to, so we ask whether B is this one. Yes, correct. Just equal to. C is this one. Yes. Okay, D is this one. Just tekan sama dengan equal to. Okay. So the next A is 0.1444. So equal to 0.2901. Press equal to 0.0736 equal to negative 0.070. Lah. And then continue. A is 0.1465. B is 0.2912. And then this one is 0.0747. Negative 0.0695. Okay, so belum boleh stop lagi because this one and this one minus is still the difference is still more than 0.005. So we have to continue for press equal, and then get the new A 0.1470. Press equal to 0.2914 equal to 0.0749. Press equal to negative, sorry, is negative 0.0694. So if look at here, this already okay, this already okay, this already okay, because the difference is 0.0002, 002, 001. But this one is still is not okay. Still 0.0005. So we still have to do another iterations. Lagi. Probably only one lah, I guess. Okay, so press equal to, and then now A is 0.1471. 0.1471. Okay, so the difference is only 0.0001. So this one 0.2915. So 0.074, oh sorry, 45, negative 0.0693. 93. Okay, so you look at here, this the difference is 0.001, 0.0001, 0.0001, 0.0001. Kan? So daripada sini, out of here, all the maximum is 0.0001 lah kan? Right. So that's right. Sin maximum, this one, x, this one, 5 minus x4 in modulus is equal to 0.0001 less than epsilon. So, oleh sebab itu, U11 is equal to this value, 0.1471 U U21 U21 21 is equal to 0.2915, and then U12 is equal to 0.075, and then U22 is equal to negative 0.0693. So done. So okay or not? Okay?
Dokter,
Yes.
nak tanya, kalau saya punya kalkulator boleh terus dapat jawapan, boleh tak saya tak mau pakai method?
Yours is a black one.
Ya,
It's 4 times 4. Kalau 4 times 4 kalau lah, okay? Let's say you have 4 times 4 matrix. So 4 times 4 matrix, you better to use some using the system of linear equation, because they probably will have mark put on there. So boleh faham? Okay, the answer, maybe you can get the answer. Sorry. This one answer, when you correct, you can get this answer, right? You can get only this mark here. Maybe this one 2 mark lah, I guess. Half all is, so this maybe can be 2 marks here.
so if 3 times 3 can directly use the calculator
Yes,
lah.
3 times 3, yes.
Okay.
Because
Doctor.
why? Because this one, this syllabus is assume that student using this one. If let's say you using that one, another one, this one, right? 4 times 4 boleh gunakan this one. The black color, this one, right?
Ya.
So this one can use. So but then you still have to do the calculation. Kalau okay, like this. How to say? Depending on the topic, okay, if let's say that topic is system of linear equations, then even that is 3 times 3 matrix, you have to solve. Okay, you have to solve using the method that's asking you to solve, either Thomas Kolesky or Gauss eliminations or Gauss Seidel. Even that is 3 times 3, you can use calculator, right? So don't use calculator, you just use calculator to double check your answer. Okay.
Okay.
Okay, so shall we take rest for about 2 minutes? Then we continue with the Poissons. And we take rest 2 minutes. Yes, Ziqing, you have any questions to ask?
No, I just want to say thank you, doctor.
Belum habis. Wait, I stop sharing. I have some link that I would like you to isi lah, to fill in, Nesby. Wait, I go and find that link first. So you can go and wash your face, drink a cup of coffee, eat some bread, go to the toilet, or continue to sleep for 2 minutes.
Doktor,
Aha.
macam ni ada isi spark tak?
Ada, saya dah share kan?
Oh ada.
Ada,
Saya
saya
beri
dah
kat situ.
ada. Memang dah mula. Okay.
Saya nak bagi full mark dekat doktor.
Tak ada, tak perlu. It's okay. You just, to be honest, just honest. Okay, now I would like you to help me to feel this one. This one is feedback. I just want to know the feedback from the students. Any suggestion or any comment in the chat box there. So you can go to the chat box and then fill in that one. Okay, we're going to start another 2 minutes.咦，妈咪上课，不要吵。我呢度啦。不要吵妈咪了吗？不要吵，你不要扭了啊！不要打开门了啊！Okay, class, can we continue? Dah okay belum? Dah hilang saya punya student ke mana dah? Pergi tidur semua. Now it's 40.
Ada.
Ada share device. Betul ke ni? Where the others dah hilang lah semua? Okay. Okay or not? We continue? We continue, okay? Can? Okay. So we
Okay, Doktor.
Okay, so we continue. I just take the example that's same with this example lah. So you see, basically, wait, I share back. I look at example. Ke tak perlu saya tulis je. Sama je saya rasa. I remember that is the same. Oh, example 9.10. Guna balik ini, just use this one. The same template. Poisson equation. Okay, so this is the example 9.10 Poisson equation. So on page 241, so you look at here, actually the condition is same like the previous example. Okay, the boundary condition, the step size sama, dia punya grid, even the x from 0 until 1, y equal 0 until 1, and the equation only have the right hand side here equal to xy. Okay, so I go back to the previous, this one. Wait, it takes some time. This whiteboard also tired already. It seems like you, I guess. Tired already, right? Saturated. Your brain already saturated. Now only these two topic. When come final, habis lah lagi. Final, you have 9 chapter to cover. Kali ni habis. Okay. Apa? Siapa nak cakap apa? Kenapa, Fatimah? Apa nak cakap? Okay. Now, sorry. So what is difference? Okay. Alamak, sorry. So step 1, steps 2 will be the same. Only step 3 kat sini. When we want to change to the final different form, the right hand side is not equal to 0. But the left hand side is still same. Here, this one. So step 1, same. We have to draw the grid, name all the grid. Step 2, consider all the boundary condition. And then step 3 is write in the final different form. So start from this one. So here, because we have the value, bukan lagi kosong. Okay, so here, so now, wait, sekejap. So I write here. So same, become ui minus 1j, tak keluar. Wait, ui minus, dah. Minus 2 uij plus if ui plus 1j. Okay, this one is ni kan 1 over 3 square. Sorry, square. Plus with ui j minus 1 minus 2 uij plus with uij plus 1 divided by 1 over 3 square. Okay, so here is equal to x and y. Here equal to tak keluar, equal to x and y. Okay, now this one I have to bring to the here, right? So sekarang now become ui minus 1j minus 4 uij plus with ui plus 1j plus with uij minus 1 plus with uij plus 1 equal to, so this one become 1 over 9 xy. So if you look at here, actually the left hand side here are still same. But same, right? So that means even this molecule graph is same. We will get the same molecule graph. Only here, the right hand side here, we have the value, to put the value 1 over 9 times xy. So the molecule graph here is same. So just use the same molecule graph. Cuma dia is equal to 1 over 9 xy. Okay, so we key in, plug in this one into the grid. this grid, yang ni. So using the same molecule graph, kan? Same molecule graph. So that means the value of the right hand side here will be changes. Bukan lagi macam ni. Tapi sebelah kiri semua sama. Okay, so let's try. We try with this one. The first, this one. Oh, sorry. This one. Okay. Now we start with this one. You see? Okay. Here, this is U12. Okay, U12. So this is U12, correct? Okay. Plus with 0, U1. Okay. Minus 4 UI. U11. Okay. Plus with U21. Okay. Plus with U10. Sama kan? Right, correct. So now here is equal to, boleh tak saya tulis kat sini? Tak tulis. Tulis kat sini boleh? Nak tulis warna apa ni? Biru. So equal to 1/9. So at this point, okay, so we have to consider based on this one, okay? So because this is our target cell. So at this point, the value of x is what? Here. So this is 1/3x. Boleh? And at this point, the value of y is 1/3 as well. So 1/3. Understand or not? Boleh? Okay. Understand? Understand. Boleh? Here. So based on the target cell, the purple color. Yang ni kan, dia punya x at this point, what is the value of x? This is 1/3 kat sini. 1/3 kat sini. And at this point, 1/3 for the y. Lambat sikit. Dia detect. Here also 1/3. So now, here you have to calculate. Bukan lagi. Okay, you bring this one 0.222 to the right, right? And then we have to plus with this one. So here I put in 1/9. Okay, time with 1/3 time with 1/3, kan? And then we have to minus this negative 0.2222 minus 0.2222. So we get negative 0.2099. So here become the new value here is negative 0.2099. Boleh tak? Okay, so when we move to the right, this one move to the right. Okay, so now our bukan. So now our target cell is this one. Now target cell is U21. So at this point, the x, they're based on this one. Penjuru here. Based on this value. So at this value, x is 2/3. Okay. And at this point, y is 1/3. Okay. So here, we have to change it. Saya sapu sini . Now, let's say. So this one will be equal to So the left side is similar. Okay, you see this one, this one is U. Okay, sekarang the second one is, sorry. Okay, so this one is U22 plus is U11 plus U11 minus 4U21 minus 4U21 plus with 0 sebelah kanan. The right side here 0.866. Ni, U22 here atas plus with the left hand side here U11 minus 4U21 here, and then plus with 0.866 this one, okay, plus with 0.2222 is bottom here, so is equal to, here now is 1 over 9 time with x, the value of x now is 2 over 3, and then the value of y is 1 over 3. Okay, boleh. Now means that here 1 time 2 times 1, and then the bottom is 9 times 3 times 3, and so equal to 2 over 81. And here these two bring to the right as well, right? Ataupun ni lah ni, this one. So we minus, so answer minus 1.0882. So we get minus 1.0635. So now the answer here is negative 1.0635. Okay, semua okay? If you're okay, then you press 1. If not okay, then you type 2. Okay, now sama. Now we move up here. This move up, this move up, this move up, and this one move here. Sorry, this one delete. This one move here. Here, okay. So now this one is the one. You see, this one 0.2222 here, 0.2222. Okay, plus with 0, the left hand side here plus with 0. Okay, minus this one, minus 4U12, and then plus with U22 here, plus with U11. Okay, so here ini, so refer to this one, this purple. Okay, this purple at this point, x is 1 over 3, and here y is 2 over 3. So that means here is equal to 1 over 9 times with 1 over 3. Here is 2 over 3. So that means 2 over 81. Tadi itulah. Kan? This one. 2 over 81. Lepas tu here, just now, this one minus 0.222. So we get negative 0.1975. So here we get negative 1.01975. Okay, negative 0 point. 0 point. And okay, now move to the right. Here, this one move to the right. This one. Wait ah. Ay, kemana ni? Delete dulu. This one. What is one? Delete. Delete this one. This one also delete. So this one and this one. Okay. So sebelah kiri, the left side will be same. Left side will be same, only the right side. So the right side here, now we have to consider at this point. This point. Now this point is x is 2/3 and y also 2/3. So here means that this one, the equation number 4, this one is equal 1/9 times with 2/3. This one is 2/3. So sekarang this one bukan lagi. So we have to calculate again. So 1 times 2 times 2. At the bottom that is 9 times 3 times 3. Okay, and then plus with 0.6438. So now we get 0.6932. So new value is 0.6932. So using the system of linear, we solve using system of linear equation. So only this part yang berubah, only this part is changing. So here, this is negative 0.2099. This one is negative 1.0635, negative 0.1975, 0.6932. Boleh. And then solve using the same method. You can use Kolesky method or you can use Gauss-Seidel iteration methods. Okay, boleh. Sampai sini okay. Can I stop here? Okay or not? Kalau okay, then you type okay. Okay, class? Nuratika, okay ke Nuratika?
Okay.
Okay. So, okay. Dah. What else? Dah kiranya habis lah. All the syllabus, the implicit, I didn't teach. Wait lah. I stop.